Our new topic is the progression. In AS level, it is divided it into two parts. One is known as to be called arithmetic progression, which is denoted by AP, and the second part is known as to be called geometric progression, which is denoted by GP. We know one thing, that in arithmetic progression, the difference between the two consecutive terms is same. And in geometric progression, the ratio between two consecutive terms is same. So we will explain it one by one with examples, and we will derive also the formula for this term and the sum of both these progressions, whether it is arithmetic progression or it is geometric progression. So we know that A1, A2, A3, A4, A5, and so on up till AN is any progression there, where A2 minus A1 is the same as A3 minus A2 is the same as A4 minus A3, and that is equal to the difference D. Then it is known as to be called arithmetic progression. Now we take the examples of this 5, 8, 11, 14, 17, and so on. So here it is A1, this is A2, this is A3, this is A4, and this one is A5. So we have seen it there, A2 minus A1, that is 8 minus 5, that is equal to 3. A3 minus A2, that is 11 minus 8, that is also equal to 3. A4 minus A3, that is 14 minus 11, that is equal to 3. A5 minus A4, that is equal to 17 minus 14, that is equal to 3. So that means the difference between all these terms is same there. So this is in mathematics known as to be called arithmetic progression. Second example, we can take it here. It is minus 4, minus 1, 2, 5, 8, and so on. So A2 minus A1 is minus 1 minus 4, that is equal to 3 there. Similarly, A3 minus A2, that is 2 minus minus 1, that is also equal to 3. Then we take this example, 5 minus 2, that is equal to 3. So you have seen it there, it is difference is equal to what? 3. So it is also known as to be called arithmetic progression there. 4, 11, 18, 25, and so on. So A2 minus A1, that is 11 minus 4, that is equal to 7. A3 minus A2, that is 18 minus 11, that is also equal to 7. A4 minus A3, that is equal to 25 minus 18, that is also equal to 7. So this means there's a constant difference D, which is equal to 7. So it is also known as to be called arithmetic progression there. Now we have to derive this formula for this part of this arithmetic progression. We know that A1, A2, A3, A4, A5, and so on up till AN. This is a general series formula for that progression there. Suppose in this case, A1, it is the first term. and we denote it by A there. Now, we know that from this arithmetic progression, A2 minus A1, that is equal to D. This means A2 should be equal to A1 plus D. But A1 is A there. So you can write this thing as A plus D. It is the second term there. The third, A3 minus A2 is also equal to D. So A3 is basically equal to A2 plus D. But A2 is A plus D. So A plus D is the second term plus D, and that is equal to A plus 2D. This is the third term of that. A4 minus A3, that is also equal to D. So A4 is equal to A3 plus D. A3 is basically A plus 2D plus D. So A4 is equal to A plus 3D. So if we carry it on, if we have to write down eighth or 10th term of that, then according to this, if it is first term, it is A, second term, it is A plus D, third term, it is basically equal to A plus 2D, fourth term, it is A plus 3D. If it is 10th term, is A is constant there, so we write it A there. Fourth, we write it here, it is a difference 3 there. For 3, you write it 2 there. For 2, it is 1D there. So it should be A10. So it should be equal to A plus 9D. If we have to write down A20, then it should be equal to A plus 20 minus 1, that is 19D. So we can write in simple form. If it is A30, then it should be equal to A plus 29D. And if it is AN, then it should be equal to A plus N minus 1D. So this is the formula for finding any specific term in arithmetic progression here. Now we can take the examples of this. 2, 5, 8, 11. Let's say we are going to find out 17th term of this progression. We know that this 2 is A, and this difference D there is 5 minus 2, that is equal to 3. Where N is equal to 17 because it is A17. So it should be equal to A17 is equal to A plus N minus 1 into D, where A is equal to 2 plus 17 minus 1, that is 16, and difference D there is 3. So it is 2 plus 48, that is equal to 50. So it means 17th term of this progression is 50 there. We take another example, -4, 0, 4, 8, 12, and so on. And you are going to find out A20 for this term. We know that A is equal to -4. The difference D there is A2 minus A1. So that means 0 minus -4, and that is equal to 4. So A is known to you, that is -4, and the difference D is known to you, that is 4. And we need A20. So A20 should be equal to A plus 19D. So A is equal to 4 plus 19 into D difference there is 4. So that is 4 plus 76, and that is equal to 80 is the 20th term of this. We can take the third example, a plus 3d, a plus 5d, a plus 7d, a plus 9d, and so on. And you are finding 12th term of this portion there. We know that in this case, this is the first term. So a is basically equal to a plus 3d. And the difference d is the difference between these two. That is a plus 5d minus a plus 3d. That thing is equal to a plus 5d minus a minus 3d. And that thing is equal to 2d. So the difference d there is 2d there. Now you are finding the 12th term. So a12 is equal to a plus n minus 1 into d. A is their first term. And first term we have calculated as a plus 3d plus n, that is 12 minus 1 into difference d there is 2d. So it is a plus 3d plus 11 into 2d r. A12 is equal to a plus 3d plus 22d, and that is equal to a plus 25d. So this is known as to be called the application of finding any specific term in this part. Now let's have the more example on this part. In arithmetic progression, the second term is 9 and the fifth term is 21. Find the first term and find the first 10 terms of that. So from this, we know that the arithmetic progression formula is an is equal to a plus n minus 1 into d. If we use this first, second term is 9. So that means a2 is equal to a we don't know, term we don't have 2 minus 1, and the difference we don't know. Let's say that is equal to 9. So this will become a plus d is equal to 9. Let's say it is equation number 1. Now we use the second condition. Fifth term is 21. So a fifth is equal to a plus 5 minus 1 into the difference we don't know, that is d there. And that thing is equal to 21. So a plus 4d is equal to 21. Let's say that is equation number 2. Now we can solve 1 and 2 there. So one is a plus d is equal to 9, and this is a plus 4d is equal to 21. Now we solve these two simultaneously. Minus, this is minus, and this is minus there. A and A cancel out. D minus 4d is minus 3d. 9 minus 21 is minus 12. So d is equal to 4. And now we can use any one there. A plus d is equal to 9. A plus d is 4 there, which is equal to 9. So A is equal to 5. So the first term of this progression is equal to A, and that is equal to 5. And the 10th term of this A10 is equal to A plus n minus 1 into D. So A is 5 plus 10th, that means what? 10 minus 1, and difference D there is 4. So that is equal to 5 plus 9 into 4. This is 36 plus 5. So the 10th term of this progression is 41. Suppose in this series, first number is 5, then last number is 71, and you are going to find out the number of terms in this progression, if it is arithmetic progression. We know that the formula for the term there is a plus n minus 1 into d. An is the last term, so that term is 71. A we have first has 5 plus n minus 1 we don't know, and the difference between this is we don't know. So, and the second term there is 11. So we can have difference d, there is 11 minus 5, that is equal to 6. So we can put it here, 71 is equal to 5 plus n minus 1 into 6. Or this should be equal to 5 plus 6 and minus 6 is equal to 71. And 71 is equal to 5 minus 6, that is minus 1. Or 6n is equal to 72. So n is equal to 72 divided by 6, and that is equal to what? 12. So the number of terms in this progression of this arithmetic is 12 there. So these are the few examples which are being explained in the first part, that you are going to have the clear concept of this arithmetic progression when the difference between the two consecutive terms is same. And now we will do the second one, where we are going to find out the sum of this arithmetic progression in the next video.